Hi, we are Team 18. I will be representing our project, Color Recommendation. The main idea of the project is to use a color sensor to detect the RGB code of an object, and by using an API, we will use this RGB code to recommend a color palette according to this object, the color of the object. We also used an ultrasonic sensor to specify the distance between the color sensor and the object. We will first start by trying the ultrasonic sensor. The ultrasonic sensor shows the distance in hexadecimal. And now we will be trying the color sensor. Now we will test the red color. Then we will test the blue color.
Now we will start talking about the details of detecting the color using the color sensor. The main idea of the mechanism that the color sensor uses to detect the color, that it outputs a square wave whose frequency is proportional to the strength of the color that is chosen by the user through the select lines. The values of the select lines can be set using the VHDL code or the C code. It depends on whether we are using an FPGA or an Arduino circuit. The sensor in general has some error in measurements, so in this video we used Arduino for the purpose of the illustration because this minimizes the error as possible as we could. However, we provided codes for both FPGA or Arduino in order to control the sensor and get color values from it. Now let's look at the details of the code that is implemented using VHDL when we connect the color sensor to the FPGA. This is the top design entity that is responsible for detecting the color from the color sensor. First, there are some imports of packages and libraries. This is the port of the entity. First, we have the output of the sensor as an input to our FPGA and the clock. Those are our inputs, and we have S. Those are select lines that we use to select which color we want to get its value right now, and those are some signals or vectors that we store color values in it. We will use it inside our architecture, as I will explain shortly. This segments port is a buffer which is responsible for showing the value of any color or all the colors on the 7 segments displays that are on the FPGA. Next, let's move on to the architecture. We have a state machine that is responsible for controlling the sequence of events that we enforce to get the values of the colors. We have an initial state, we have reading red color state, reading green color state, reading blue color state, and a delay state. The delay state is put between the reading of every 2 colors to avoid confusion between the readings of different colors. This signal is we store the current state in it. Then this signal is next state. I will explain shortly what it is doing. This signal count edges is responsible for measuring the time of the time of the signal that is coming from the sensor, the square wave that enables us to know the value of the color we are selecting. Count enable is a flag which we use to start and stop counting. Those three signals are internal signals that we store also the color values in it to use in some circuit below. This delay counter, which is used in the delay state, the previous out value is also a flag that we use to detect the rising or falling edges of the square wave that is coming from the sensor. And finally, there is a constant delay limit that is used to state or control the length or duration of the delay state.
Let's see our ultrasonic sensor. Here we have some inputs and outputs. Here we have echo and a clock as an input. Also we have a trigger and segment as an output. Segment actually help us to represent our distance into different 7 segments in hexadecimal. Here we have architecture. We also have a process here that every rising edge we do a specific amount of operations. First thing, we increase the cycle by 1 cycle counter. This cycle counter, it's just as a counter for time. It has an upper limit. This upper limit, this number, we read the distance every this amount of cycles. Here also we set a trigger for a specific amount of time. This trigger is set to 1 in order to trigger our sensor to output or send a sound wave that will help us to calculate the distance later. Actually, when this trigger is set to 1, echo is set to 1 for a specific amount of time. As long as this echo is 1, we just increase our distance counter 1 every clock cycle. This condition is for just to enforce or to maintain that we don't measure more than this amount of distance. Here at the end of each period of time, we just calculate the distance and set our variables to 0 or these counters. At the end after the process, we just output our distance in 2 different 7 segments. We'll see how this binary to hexa works. Actually, binary to hexa is just some hard coding. Just we see the number, how it's represented on the 7 segment, and we set the high lid or the open lid with 0 and the off lid with 1. That's it for the ultrasonic.
This is the Arduino code we used for measuring the color frequencies. First, we will have to assign to each pin a variable. We have 4 outputs and only 1 input from the color sensor. 2 of the outputs are for scaling the frequencies and 2 are for selecting the color. We will be using a 100% frequency scaling, so we'll have to set S0 to 1 and S1 to 1. We will be using a variable to store the input, and for each color we have to know its maximum and minimum frequencies. We will start by reading the red color, so we'll have to set S2 to 0 and S3 to 0, and we read the input from the color sensor and store it into a variable, and you have to make sure that the input is inside the range of the maximum and minimum frequencies. And finally, we have to print the data after mapping it into values between 0 and 255. And between each 2 readings, we have 20 milliseconds delay. And we will now read the blue color, so we'll have to set S2 to 0 and S3 to 1. And finally, we have to read the green color, so we'll have to set S2 to 1 and S3 to 1.
Now this is the final stage of our project, in which we suggest colors which matches the color given by the color sensor. And these colors is provided by a free API and this API is implemented in Node.js. A framework is used to implement some backend for websites. Now let's have a look at the code. Here we take the RGB from the color sensor, and then here we take this RGB and give it to the API as an input too, but to the API. Then we take a palette as an output from the API, from the request to the API. Let's give some example with some numbers to clarify. Let's begin the server. Okay. Here we can say, for example, a red color, which is 255 red, 0 green, 0 blue. And this is our palette, and this is our color. Let's say we have green color like this, and we are, let's say we have blue color. We are provided by this palette. Let's say we have a gray color, and this is the result. And that's it. Thank you.